ናችሁ ላስት ዊክ ፓርት 2 ላይ ፋውንደሪ እና የርሲ 20 ኢቨንትስ እና የርሲ 721 አይተናል። Excuse me, so this class will be on gas optimization. Alright, so gas optimization, it's not like kind of new concept, especially የሆነ ዌብ3 ላይ ያለ ብቻ ኮንሰፕት አይደለም። ከዌብ ቱ የመጣች ዴቨሎፐሮች or almost all of us, then we know optimizing code or optimizing your SQL queries to be more efficient and more like less space እንዲጠቀሙ ወይም ደግሞ like less runtime እንዲኖራቸውም እናደርጋለን ዌብ ቱ ላይ እና ጋዝ ኦፕቲማይዜሽን በሶሊዲቲ ኮንሰፕት it's the same case like ኮዱን ኢተሬቲቭሊ የተሻለ ፐርፎርማንስ እንዲኖረው እና ሌስ ስፔስ ኦር ደግሞ ሌስ የሆነ one time space እንዲኖረው ማድረግ ነው። or like we'll get to the details now. You can finally make your own generalization into what it means. ግን generally gas ማለት is the cost for running your transaction ማለት ነው። ለምሳሌ if we take any Etherscan transaction, there is gas linked to it, like many gas for that transaction spend ተደረገ እናያለን transaction ላይ. So let's just take this transaction. Yeah, I have a little bit slow internet, so bear with me. Anyways, we'll get back to this CCAFT. So you'll see that there's gas assigned to that transaction, and that gas is used like to execute all the opcodes of that function ወይም ደግሞ የዛ invocation ማለት ነው። so gas optimize ወይም ደግሞ your gas ነው እዚህ ላይ like minimize የምናደርገው. So there are different techniques, but we will have a hand-on experience with the logics here, and we're not going to go over all these details again. Once you grab the concept, then you can like dig more and understand or see the other cases on how to save gas ማለት ነው. So one of the good examples that I like is the minimizing on-chain data. So we have a good example here. So you see this contract struct and defined የሆነ data struct አለው here. So votes የሚባል ደግሞ based off of that struct define የተደረገ variable አለና every time when the vote function is invoked ምንድን ነው የሚያደርገው የቮተሩን choice true or false ሲሆን or some yeah definitely true or false pool ስለሆነ እሱን ወደዚህ ቮትስ አሬ ውስጥ ፑሽ ያደርገዋል። አንድ የዲስ ኢንስታንት የቮት ኢንስታንስ ፈጥሮ ማለት ነው። ሶ this votes የሚለው array of this vote ማለት ነው የሚይዘው። ስለዚህ this is still viable and still doable, ግን the problem is like this is not very efficient አይደለም ምክንያቱም we're saving this on chain, but rather we can do something called events ወይም ደግሞ like we are not storing the transaction or the data on like contract ላይ ሴቭ እያደረግን ሳይሆን as part of the logs emit እንዲሆን እናደርገዋለን, which is ደግሞ still available to later on return ለማድረግ ማለት ነው, ቼክ ለማድረግ ወይም ደግሞ ፑል ለማድረግ ዳታውን still እንችላለን. So this is the storage based የሆነው ነው, ይሄ ደግሞ event based የሆነው ነው እና we will see the optimizations ወይም ደግሞ the gases they use ማለት ነው. Okay. So you can see the gas difference here. But huge gas difference when the contract uses storage. You can see how much gas it requires, and then when it uses the event demo, you can see there's like big difference on the amount of gas that needs ማለት ነው። እሺ so using mapping over array is the other techniques. So actually ይሄኛው በጣም ዌብ 2 ላይም በጣም ቤዚክ ነገር ነው። I don't know if you guys know about hash map. Hash map ማለት yes, hash map ማለት ለምሳሌ we have array of objects, let's say a እኩል ነው or id እኩል ነው 1 and a name እኩል ነው አስቴር and goes on ማለት ነው። id እኩል ነው 2 ብለን then we have we have the name attribute here በቃሉ እንደዚህ ያለ ይቀጥላል። But this is not efficient way of storing this data. I mean, like we can do something like this. Hash map ሆኖ id was done, then id could be mapped with the object details ማለት ነው። So this is the same thing with the techniques that we are seeing here using mapping over array ማለት ነው። So ይሄ የአሬይ አፕሊኬሽን ወይም ደግሞ የአሬይ ኢምፕሊሜንቴሽን ነው። ሶ ዊ ሃቭ ዩዘርስ እና የዩዘሮችን ባላንስ ስቶር እያደረገ ነው። ሶ የዩዘሩ አለ ዴን ባላንሱ አለ ዴን ዩዘርስ አሬይ ውስጥ ፑሽ እያደረገ ነው። ሶ ዩዘር አድሬስ ላይክ ዩ ካን አስዩም ኢት አዝ አን አይዲ ኤንድ ባላንስ ላይክ አዝ አ ኔም ለዚህኛው ኤግዛምፕል ማለት ነው። ሶ it's not efficient for two reasons. አንደኛ ይሄን ነገር ፑል ስናደርገው we have to iterate through all the users to get the user that we want ማለት ነው። ስለዚህ ይሄ iterating over all that users ደግሞ it would make it like to process like በጣም ብዙ አፕ ኮድስ እና እሱ ደግሞ ምን ያደርግብናል like ጋዝ ኮንሰምፕሽናችንን በደንብ ኤስካሌት ያደርገዋል። ስለዚህ we have this mapping implementation here and እዚህ ጋር ግን like directly user balance of this user id ብለን we can get the balance. So this is also a good trick and yeah, we will check the gas comparison for that. Balance ሲጠራ the gas cost is like 3 million ምናምን ነገር ነው። ግን በማፒንግ ኢምፕሊሜንቴሽን ደግሞ የሰራ ነው የዩዘርስ and balance mapping. You can see the gas cost is like very much lower than compared to the array based የሆነው የዩዘር and balance implementation ማለት ነው። So as I first explained, it's an optimization which is like using hashes over arrays ማለት ነው። So yeah, as I first said, this is a very high level overview of what gas optimization is, and I'll let you guys to dive into depth and see what other techniques are used. Yeah, I mean እዚህ ጋር like we can dive deep into ምን አይነት ነገር happen እንደሚያደርግ like what happens when it iterates እዚህ ጋር የራሱ variable introduce ያደርጋል እሱ ራሱ ሌላ space ይይዛል and by the way one thing የኢቴሪየም yellow paper ላይ Ethereum yellow paper op codes እነዚህ አሉና you can see each op code ምን ያህል ኮስት እንደሚያደርግ yellow paper ላይ አለ። so like data save ስታደርጉ የትኛው op code እንደሚጠራ ማየት ትችላላችሁ እና የትኛው op code የትኛው ኦፕኮድ ኤክስኪዩት እየሆነ እንዳለና ኢቨን ኮምፔር ለማድረግም የትኛውን ኦፕኮድ ኢን ኮምፓሪዝን ለመጠቀምም ይሄ ሪሶርስ በጣም ይረዳቸዋል። ያ ዛሬ ኢንተርኔት ጥሩ አይደለም። ይሄ ነገር ሲከፍት ሼር አደርጋችኋለሁ። ኦኬ ያ የቅድሙ ትራንዛክሽን ከፍቷል። so the gas fee, as you can see here, yeah, by the way, after the recent Ethereum upgrade, especially not the ones that are proof of work on ወደ ስቴክ የቀየረውን ሳይሆን የምላችሁ there were recent upgrade on the fees. I forget the EIP name, ግን ምን ቀይሮታል መሰላችሁ? የጋዝ ፊን ቀይሮታል። ኖርማሊ ቤዝ ፊ እና ሪዋርድ ፊ አድርገን ነው አሁን እንትን የምናደርገው ብሮድካስት የምናደርገው። ያ ኢትስ ኢአይፒ 1559 ማለት ነው። ከዚህኛው በኋላ ያ ቤዝ ፊ እና ሪዋርድ ፊ ይኖረዋል ማለት ነው። ሶ ዩ ካን ሲ ምን ያህል ጋዝ በርን እንደሆነ። this are by the way Ethereum representations ናቸው። I think we have covered them the past week. እሺ የሎ ፔፐሩ ከፍቷል። ኦኬ ናይስ። ሶ እነዚህ ናቸው ኦፕኮዶቹ እና የኤች ኮስት ምን ያህል እንደሆነ ማየት ትችላላችሁ። yeah, all right, so let's go ahead. So the other advantage or the other optimization tip is to use constants over immutables. So ይሄ የስማርት ኮንትራክቱን cost still lower ያደርገዋል። this is because when we define the variables, if we define them like immutable ወይም ደግሞ constant ብለን define ስናደርጋቸው they are assigned exclusively during the contract creation, and they will become only read-only የሚሆኑት ከዛም በኋላ so as opposed to the other variables ለምሳሌ ከላይ usersን define እንዳደረግ ነው ይሄ constant አይደለም። contents of it is dynamic, even the size is also dynamic. ይህንን ዲፋይን ስናደረገው ግን ላይ ኮንስታንት እና ኢሚቴብል ቫሪያብሎችን ዲፋይን ስናደረግ the chances of being it updated is 0, so as a read-only variable የሚሆኑት እና they will be ደግሞ part of the contract when the contract is created ማለት ነው። so we have a test for this. By the way, this is the Cephrin resource, በጣም ጥሩ ሪሶርስ ነው። they have also the GitHub repo for all this tips. እሱን ክሎን አድርገን ነው እዚህ ጋር ያየን ያለ ነው። okay, so constant እና immutable ስንጠቀም you can see the gas difference here. እዚህ ጋር with constant እና immutable የሆኑ variableዎችን define አድርገን ነው። ግን imagine if they were like normal variable, like normally variable እንደምንጽፈው እንደዚህ ቢሆን እንደዚህ እንጽፈዋለን ማለት ነው without the immutable እና constant የሆነው identifier ማለት ነው። So you can see the gas for it is so much different. Now this is one of the gas optimization tips. So the other በጣም ትሪኪ የሆነው payable መጠቀም ነው. I don't know if they have it here. Let me check it. So functions, sometimes they could be payable. What it means is that if we make the transaction as payable ምን ማለት ነው? ሰው ይህንን invoke ሲያደርግ they can pass Ethereum token to this contract or this function ማለት ነው. So deposit or የሆነ some Ethereum pass ይደረጋል ማለት ነው for this function. So payable ብለን define ማድረጋችን under the hood ምን አይነት ቼኮችን ሪሙቭ ያደርግልናል? There's what do you call payable ከሆነ it's not going to check Ethereum ይለፍ አይለፍ ወይም ደግሞ payable ነው አይደለም የሚለውን ቼክ አያደርግም under the hood ያለው የስማርት ኮንትራክት ኤክስኪዩሽን. So payable ብለን ዲፋይን ማድረግ ሞስትሊ ምን ያደርግልናል ማለት ነው? gas ኮስቱን ስቲል ሚኒማይዝ ያደርግልናል. So let's see that in practice. So መጀመሪያ let's remove this payable now. Let's take note of the gas it would cost. So here voting was a storage now. So I'm gonna run this again. So you see, first we run it with the payable modifier, and because of that the gas has decreased from this one, which is now like a payable function now, and around 2000 and I guess around 1900 gas save እናደርጋለን ማለት ነው. So that's also another tip. ከዛ ውጪ from Solidity 8 onwards we have the maths library, which checks for underflow እና ለoverflow take care የሚያደርግልን ማለት ነው. ነገር ግን ለምሳሌ I think we've seen this Ethereum ERC20 ላይ እናየዋለን ይሄንን logic by the way. Let me check if I can get it quickly. Token ERC20 here, unchecked. Yes. Yeah. So the reason we have this unchecked የሚባል ኮድ ብሎክ ያለን ለምን መሰላችሁ? ቅድም እንዳልኩት after Solidity 0.8 internally ምን አለን? ቼክ የሚያደርጋለን ለምሳሌ a plus b እያልን ከሆነ a plus b overflow እንደማያደርግ ቼክ የሚያደርግልን ማለት ነው. ለምሳሌ I can say you int 256 of a and define narg, you int again let's say I want 288 not 256 of b, define banana again later on, or we can say let's remove all this እና ምን ማለት እንችላለን? where's the user balance? እዚህ ጋር get balance ላይ ለምሳሌ የዩዘሮችን ባላንስ መደመር ፈለግን before returning it, so we can say user balance of address 0x የዚህን ባላንስ ከዩዘሩ ጋር መደመር ፈለግን። so this would work and it has no issue, but ምን ልላችሁ ነው, if we have this unchecked column to make some arithmetic operations, ምን ያደርገዋል? under the hood ያለውን የኦቨርፍሎው እና የአንደርፍሎው ቼክ ሪሙቭ ያደርግልናል። ስለዚህ አንቼክድ የሚለውን መጠቀማችን that's also another tip for saving gas ማለት ነው። and by the way የፔይብል እና የአሁኑ የአንቼክድ logic, they are like good approach in terms of saving gas, ግን they come with their own risk. ለምሳሌ if we have unchecked እና like very vulnerable የሆነ ኮድ የምናሮጥ ከሆነ we can run into sometime in the future when a problem ሊገጥመን ይችላል. so yeah, just be careful when you use this unchecked and payable thing ማለት ነው. alright, okay, this is very basic. Unused variable, definitely they by themselves still going to cost us some gas. Let's make sure that we remove them. Right, this is interesting one, by the way. So when you delete unused variables, you get 15,000 units of gas refund for each variable ማለት ነው. And the reason for this is because of storage costs ስለሚያደርጋቸው ነው። ለምሳሌ ማይነሮች when they mine the transactions, the data is being saved on their node, and if you are like deleting resources, then that would decrease the amount of size that would be saved in the whoever runs the node. So that's why this gas refund logic is there. So here data and ለሶስት ብሎ ምንም አያደርገውም አይጠቀሙም or even a return ቢያደርገውም that's okay. ግን you can see later delete ሲያደርገው reset ስለሚያደርገው to its default value for that execution gas refund ይኖረዋል ማለት ነው. so yeah, we can run this one as well. okay, እሺ so with delete ይሄን ያለው, but without delete it's costing around 200 or 20, is it 20,000? yes, around 20,000 extra gas cost ማለት ነው. ስለዚህ make sure you delete a variable, especially after using it, then what a default value reset ስለሚያደርገው you will get some gas back ማለት ነው. so this is also a good approach. alright, so the other trick is like using fixed size array over dynamic array. ይሄ ለምንድን ነው? ፊክስድ የሆነ አሬ ስንጠቀም the length for it is known, like it's known. It's like when a value is known, ቅድም አይተናል, when we use constant and immutable, we don't have the cost of making sure that variable is updated or not. so እነሱ አይነት cost ስለሌለብን we have like less gas ማለት ነው. so it's the same thing here. when you define a fixed size array ማለት ነው, the cost is for or comparing it with the dynamic sized ones, the size for it is like less because the EVM store doesn't need to keep the length of the array readily available in the storage. so it just saves the what do you call the size for that array, and no more need to update that. So that's also another tweak. Okay, yeah, the other one is using less than 256 bit if necessary, or if it works. ለምሳሌ ብዙ ጊዜ ይሄ የሚሆነው ለታይም ስታምፖች we don't need to use the uint 256 because it's like very big size now ለነሱ. So if you use, I guess 32 is fine for a timestamp. So that's also another way of saving gas. In short, ምን ማለት ነው ይሄ 256 ቢት የሚሆን ስፔስ on the storage slot ነው dedicate የምናደርግለት. So ግን for your time we're not going to use that much of it. So it's like minimizing the amount of space that is needed by that variable ማለት ነው. Okay, so this is also another gas optimization trick. ይሄ ደግሞ እንደ መሰላችሁ የሚሰራው so normally ኮንትራክቱ ዲፋይን ሲደረግ ከላይ ጋር ላይክ ቫሪያብልሶች ምናምን ዲፋይን ይደረጋሉ እና so እያንዳንዱ ቫሪያብል has ዴዲኬት የሚደረግለት ስሎት አለው። so ይሄ ማለት ለምሳሌ ይሄንን ቫሪያብል ውሰደው እና let's say እዚህ ጋር አንድ uint 256 some variable ብዬ የሆነ ቁጥር ሰጠሁት 14 ከዛ some variable 2 ብዬ ደግሞ ሰጠሁት። so ይሄኛው by itself it will take one slot full one slot ይወስዳል። ከዛ but let's say I have defined uint ለምሳሌ 128 የሆኑ a የሚባል define ባረግ and another uint 128 b የሚባል okay already a እና b ያሉን a b እንበላቸው እንደዚህ define ብናረግ this two together will take the second slot ማለት ነው። so ሁለተኛው slot አንዱ slot like 256 fit ማድረግ ስለሚችል these two variables will fit on the second slot ማለት ነው። ግን if I didn't define this or if I define them later ምን ይሆናል መሰላችሁ የሚቀጥለው boolean ነው። boolean is not, it's just one bit, true or false. ግን it by itself will take another like full slot ይወስድብናል። ምክንያቱም የሚቀጥለው variable 256 ቢት ስለሆነ ከዚህኛው variable ጋር አብሮ ፊት ስለማያደርግ በራሱ ሶስተኛውን ስሎት ይይዛል። ይሄኛው ደግሞ ሁለተኛውን ስሎት ይይዛል። so እዚህኛው ሁለተኛው ስሎት ላይ ወደ 255 ቢት ዌስት እያደረግን ነው። we are only using one bit storage ማለት ነው for the boolean። ስለዚህ when you define these variables, make sure that they are like in a right order so that you can have optimized resource usage for the storage ማለት ነው። Alright, this is also another good trick, but the thing or like what this tutorial is trying to say is different. ይሄ እያለ ያለው this small bit የሆኑትን together define አድርጋችሁ ፓክ ማድረግ ትችላላችሁ። እሱን የሚለው oh sorry, it was actually saying the same thing. ምክንያቱም first boolean define ያደርጋል, then uint 256 and define ያደርጋል, then another boolean define ያደርጋል. so this take another first storage ይወስዳል first storage slot, this will take the second storage slot, and this will take another 3 storage slots ማለት ነው። ግን እንደዚህ ዲፋይን ብናረጋቸው ሁለቱን ቡሊያን አጠገብ ላጠገብ አድርገን ዲፋይን ብናረጋቸው this two together takes like one slot ፊት ስለሚያደርጉ በአንድ ስሎት ውስጥ ማለት ነው። ከዛ ይሄኛው ደግሞ the second slotን ይይዛል ማለት ነው። So this way when we put this smaller variables together we can pack them together ማለት ነው። Okay, as I said earlier, this is a kind of high-level overview, and you guys are very welcome to dive deep, and if you have any question ደግሞ next classoች ላይም raise ማድረግ ትችላላችሁ። So yeah, the compiler optimization, I think in the assembly Python I think እንጨርሳለን። yeah, so these runs are like the iteration it will take to change this solidity code to a machine readable code ማለት ነው። so this solidity compiler like iterate ያደረግበትና kind of it makes it like very cheap for gas and for execution ማለት ነው። so this iteration, if the iteration is high number እዚህ ጋር እንደምታዩት ምን ይሆናል ኮዱን ኦፕቲማይዝ ያደረገውና it will be like we will have cheaper cost for execution ለኮንትራክቶች ለፈንክሽኖች execution cheap ይሆንልናል። so but if the runs or these iterations are like very low ምን ይሆናል መሰላችሁ ዲፕሎይመንት ኮስቱ በጣም ሲምፕል ይሆንና የኤክስኪዩሽን የፈንክሽን ኤክስኪዩሽን ኮስቱ ግን it's not going to be the same as when we have it with a high number ማለት ነው። so we need to find a balance between these two numbers. so you can definitely kind of like put some Excel and kind of run it over and see the balance for it. especially ይሄ ነገር በጣም serious የሚሆነው when we deploy contracts to the mainnet ነው። ምክንያቱም we want like the deployment for the contract to be the minimum cost, and also we don't want to push users demo from the platform just because we have like we made it very cheap for the deployment now. It's now very expensive to invoke the functions, so we need to find the balance for the runs ማለት ነው። all right, የመጨረሻው is to use assembly. so I don't know if you guys have seen something like this, but you can run assembly code inside of solidity code under this assembly bracket ማለት ነው። so this, as you guys can guess, it makes it like very easy for the execution to the machine. so since it's assembly, it's very close to the machine code or on how the machine reads or how the machine understands ማለት ነው። so it's obvious reasons for that reason then we will have less gas when we use this assembly keyword ማለት ነው። I mean not assembly keyword, when we use the assembly check እና እንደገና ደግሞ our logics inside of it ሲሆን ማለት ነው። but this is also very tricky, and whenever you use this especially in production, you have to be very careful on that you didn't create any vulnerability to the code ማለት ነው። yeah, so all in all, gas optimization, as I initially explained, it's just reducing the gas cost for your smart contracts. So it's improving the efficiency of it, and also minimizing or optimizing the storage usage, and እንደገና ደግሞ with some other tricks or understanding how the EVM እንዴት run እንደሚያደርጋቸው you can see this kind of options to minimize the cost of the smart contract ማለት ነው። Alright, yeah, that's it. Make sure you check this link now. I'll share this link with this video, and also clone this repo and you can play around with it.